Hi, welcome back. In the last video, we focused on frames of reference and displacement. Now we're going to move further a little bit, and we're going to talk about average velocity and speed. So, an important aspect of motion is to describe how fast the object is moving. Okay, and where does this come from? This is the average speed of an object. So, the average speed of an object is defined as the total distance traveled along its path divided by the time it takes to get or to travel that distance. So, the way we want to think about it is speed is going to be distance over time. Okay. Or we can just simply say it's going to be x over t. Now, on the other hand, the other way we can answer this concept or this idea of how fast is velocity. Velocity is used to signify both the magnitude and direction of the motion, right? And so this term magnitude, right, that's just simply our numerical value. It's a word that trips up students because they don't have an idea of what they forget what it means. But anytime the question says, what is the magnitude? You're just writing the number. Okay. Now, velocity is a vector quantity, speed is a scalar quantity. What's the difference? Well, vector needs a direction. Okay. And so velocity, right? And so that little kind of half arrow is our symbol for vector. So velocity is change in position over change in time. So it's going to be delta x over delta t. We will kind of transition into this concept of instantaneous, and that's going to be in the next video. Now, the average velocity will be defined as the object's displacement, okay, or is defined using the object's displacement and not the distance traveled. And that's kind of the equation I just wrote. Now, it is always important to choose the elapsed time, or what we call time interval, so delta t, which is the time that passes during a chosen period of observation. Majority of the time, yes, this is going to be t minus t0, but a good portion of the time, t0 will be 0 seconds. So a lot of times it's just whatever time is presented to you in the problem. And so if we look at some things about like last in AP Physics 1, a lot of AP Physics 1 centers around the word average. And what we're going to do here in AP Physics C is we're going to expand that now and to include now what we call instantaneous. All right, so here's just a quick example. So it says here the position of a runner is plotted as moving along the x-axis of a coordinate system. During a 3-second time interval, the runner's position changes from x equals 50 meters to x equals 30.5 meters. What is the average velocity of the runner? Right, and so we're going to do v, or our vector, right? Average velocity is equal to the change in position or the displacement over the time. Now, this is a case where they only give us a single time, which means that our t0 is 0 seconds, right? So whatever time we're going to plug in for delta t is going to be 3 seconds. And so I'm going to do my final position minus my initial position. So note, this velocity will end up being negative because of how they change their position. So I'm going to go 30.5 minus 50 over 3 seconds. Okay. And when you plug in, just to kind of plug in to the equation, you don't have to put the units, but make sure in the end you put the units. So that's going to be, this is going to be negative 19.5, and we divide that by 3. And so my average velocity for this runner's travel is going to be negative 19.5, or not negative 9, sorry, not 19.5, but it's going to be negative 6.5. Okay, so this question talked about velocity. If I'm doing speed, right, I'm going to do the same thing. So they only travel 19.5 meters, right? And so if I'm doing the speed, it's going to be the same thing, but the difference is going to be I don't have to put the direction. So common ways for direction, positive, negative. Even if the problem says, gives you a compass direction, we always tend to go back to our positive and negative, right? So if it's to the right, or if your position increase, it's positive. If your position decrease, it's negative. Okay. As I mentioned, we're going in physics C. We now will talk about instantaneous velocity in addition to